Hi guys, this is Eric Chevallet with Bearing Point speaking, and you're listening to 5 Minutes Ahead. So today I have the pleasure to have with me Rafael Pagés. Pagés? Wow, it's hard for me to say. In French we say Pagés. Rafael, I'll let you correct me on that. From Volograms. We're going to discuss today about deep tech, AI, and what it means to basically run solution like this. You probably have seen my avatar. If you've been following us on LinkedIn, you must have seen my hologram actually announcing the podcast. And that hologram was done with Volograms. So, Rafa, maybe I'll let you introduce yourself and what you do before we go deeper into the discussion.
Definitely, and thanks so much for having me. By the way, you pronounced my last name correctly. It's Pagés, although I also accept Pagés because it has a kind of a Catalan and French background, I guess. So that's how you would pronounce it in French or in Catalan. So, but Pagés, it's how I do it.
Okay.
And yes, well, I'm the co-founder and CEO of Volograms. We are an Irish startup based in Dublin, and what we do is we have an AI technology to turn videos and photos of humans into 3D models, basically. So you can create these holographic messages, just recording them using one single camera, one single viewpoint, and our AI technology is able to extrapolate and create this amazing holographic representations of people that then you can use to, I don't know, pitch a podcast, for example, pitch a new product, or to use it for all kinds of marketing activations and communications. It's actually a really good way of delivering messages that is very effective and it's very, let's say, engaging. It's pretty amazing to see how people are using it right now.
That's good. So how did you come to the idea of the hologram? Was it your first intention, or where did you start and when did you start?
Yeah, so Volograms started already 5 years ago in 2018. We are a spin-out from Trinity College in Dublin. So Jan, Costas and myself, the three founders, we were working together at Trinity College in Dublin, and we were looking to develop technologies that would allow us to create more content for virtual and augmented reality, which were, I guess that at that time it was the time where the HoloLens was announced, and when the Oculus Rift and the Vive, the HTC Vive, all these VR headsets, and there was not that much content in them. So we, from an academic perspective, we were trying to generate more ways of creating new content. So the way we started was basically trying to replicate the bullet time effect in the movie The Matrix, if you remember, when Neo jumps and the camera moves around.
Yeah.
But we were trying to do it with a lot fewer cameras, because the original recording or the original setup was using 100 cameras, kind of placing kind of a ring structure and then inside of a green screen studio. So we were trying to do it with 5 phones, outdoors with moving subjects. So basically everything that can go wrong all together into one single scene. And to be able to do it, we built this 3D reconstruction algorithm that worked with a very reduced number of cameras. And that ended up being the beginning of Volograms, because for the first couple of years, we were focusing on doing, let's say, in-studio captures with relatively small studios that only use standard cameras. So that was the origin. That's how we started creating this volumetric models or holographic models, if you wish, that a lot of companies have been using for their own purposes. And we started serving these creator ecosystem and communities.
Okay. And how complicated it is to move from 100 cameras to 5 to 1, because the now you basically using only one camera facing the guy recording his hologram, right?
Yeah, definitely. So it is complicated, but I guess that it is there's also like a road or a path to get to that point. So for us, it makes a lot of sense, right? So we started trying to build this solution that would work with almost any volumetric capture setup. which meant that we had to take care of the capture side, we had to take care of the processing side, and also the delivery, so the encoding, the compression. There was many different parts of a massive, very large pipeline of 3D reconstruction. So when we decided to go and do it with one single camera or one single viewpoint, we had to significantly change this pipeline. But we already had parts of the pipeline already kind of built that were common. We could do the tracking, the compression, the encoding was very similar. Part of the segmentation was also very similar. So part of the more high-end professional pipeline could be used also for the monocular single view 3D reconstruction algorithms. So we had to change the way that we were doing things from a, let's say, business point of view, from a marketing point of view, and of course from a technology point of view. But we wouldn't have been able to do something like that if we first weren't for a couple of years, doing professional high-end captures. There's an important point there to mention also, which is that as you mentioned, we're an AI company, right? So we do this with AI, which means that you need a lot of data to train the AI algorithms to be able to learn how to get a 3D model of a person. And we train these algorithms with the models that we were capturing in the professional studios. So having the professional business before having the, let's say, the monocular business helped us generate this massive database of photorealistic 3D models of humans that then we use for training the data. So I guess that's adds another layer of complication to the whole process.
Okay, so it's an interesting comment that you make, because we like a year ago the metaverse was very high was an hype. Now we're talking about generative AI as another hype. I think people confusing generative AI, and it's not very clear. So can you explain us in a little bit more detail what it means by training the AI algorithm to recognize or to be able to build a 3D capture, basically? What do you tell by that?
Exactly. So there's a lot of points here. When you're talking about AI and generative AI, which is just, let's say, one part of what AI is, you're talking about teaching a computer or an algorithm to think basically like a human does. It's of course oversimplified, but what you do when you're a human, you're basically learning by seeing things many different times and learning patterns in these things, right? So you don't learn what an apple is by getting a set of instructions like it has to be round, it has to be green or yellow or red, it has to come from this type of tree. No, you see an apple and again and again and again and again, and you get used to seeing that. That's basically training that we get in our minds, and most of AI works this way. So sometimes you need to see a lot of data to be able to understand how an image is, a pattern to recognize a person or to identify something, or to be able to even predict what somebody's going to be saying, right? So this is what I mean by training. We basically taught an algorithm to understand or to be able to explicitly show you the shape of a person, let's say where the arms are, the legs are, the shape of the face, just by looking at that person from one single angle, right? So from the front, typically. So you get a photo, and from the photo, we're extrapolating the full 3D shape and also the colors of the person. So this means that once you get the 3D model from that photo, you go around the 3D model, and you're able to see the back of the person, while you were never given the algorithm how the back of your head looks or your back looks. So the algorithm itself has learned the necessary patterns to figure out what the shape and appearance of a person is just by looking at that person from one single viewpoint. And for that, it needs to see a lot of 3D models because otherwise it is impossible for the algorithm to know, how it should look.
So, Rafa, how many people did you use to train the model? And at the beginning, I assume you were in the studio. So, how many people are we talking about to make sure the algorithm knows what it's doing, what he has to do?
Yeah, definitely. So there, as I mentioned earlier, for the first couple of years at Volograms, we were focusing on capturing people in studio. So, for instance, the the studio that we have in Dublin has 12 cameras. So it's able to basically get a full 3D reconstruction, full 3D accurate 3D model of a person from every angle. But we were also doing captures in other of our partner studios. So we had, for instance, Samsung XR Studio in Dallas in the US. We were doing captures in their studio, and they had 80 something cameras. I think it was 84 or 86 cameras. So you could get very, very high end, a lot of details from each capture. And the other interesting thing is that you get, every time you do a recording, say for instance that you're doing 1 minute of a recording, or let's keep it simpler. If you're doing 1 second of volumetric video, you're getting, if you're shooting at 30 frames per second, you're getting 30 3D models for each second that you're capturing. So that person that is speaking, as you were speaking, in your capture, imagine that you're doing it in your studio, you're moving, you're dancing, you're actually doing a lot of gestures that are very natural. So you get a lot of diversity of 3D models by each of these captures. So we've had a database of more than 60,000, so 60,000 3D models in our backend that we use for the captures. Of course, some of these captures are of the same person, so we have to be very careful also, so the neural network doesn't overtrain into a specific person. But there's a lot of variability in terms of genders, body shapes, in terms of clothing items that people are wearing, all kinds of movements. Also, like there's dancing, there's like more speaking, like there's a little bit of everything, and that's fundamental also if you want your algorithm to be able to recover as many types of movements as possible.
I see. And the model, is it I'm curious, is it still learning, or do you reach a level where you don't need to train him anymore? How do you get it better, basically?
So we are training it all the time in different ways. Of course, you can refine it and continue to train it so it gets a little bit better. But basically, what we do is that we improve also the input data that we provided to it. So when we started, we were only giving it the let's say the segmentation mask, so the person subtracted from the background, let's say, plus the color image, and that was everything that it needed. But with time, we started to add more layers on top of it. So for instance, now we also have semantic segmentation. So we also give it like labels about this is your jumper, and this is your trousers, and this is hair, this is right arm, left arm, things like that. So that information is very useful also for the algorithm to be able to get as accurate as possible result. But we also given it other type of input data like photometric normals. So we have a neural network that is specifically trained to get photometric normals, and that's really good because it also gives you more details into, let's say, if you're wearing a shirt, it will give you the color, or it's able to give you like some facial details that we were not able to retrieve at the beginning. So every time we had a new layer, we have to retrain the whole neural network. So, and that takes some time, as you can imagine. So we try to improve this. We do it silently, so we don't sometimes announce it until it's totally proven and people are already seeing the improvements. But we keep adding these layers and this type of information to the network so it can get better and better.
Okay, and does it mean that every time you're adding a new layer, you train on the 60,000 model that you already have in database, or you as well every time get new models on top of that?
Yeah, so that's the other point. So you can also, we still every now and then do professional production. So every time there's a new professional production, we add those those models to the training database. So yeah, the database keeps improving too.
Okay. So tell us a little bit more about your latest product, the hologram messages, because and I experimented it for the podcast, as I said in the introduction, and basically I was filming. Well, I didn't use my phone. I could have done it with my phone, but the sound was not good, so I actually went to a studio to take to have my video for 30 seconds, and it's a new product, right? It's a very recent launch that you made. Can you tell us a little bit more about the hologram messages?
Of course. I mean, everything that I've been telling until now is basically focused on the technology, on the backend technology, right? Everything that we're doing under the hood to go from a 2D photo or a 2D video into a 3D model or into a volumetric video, right? But of course, this is not a final product. That's just the core technology, and the final product is always whatever our creators do with it. So typically, we've been focusing a lot on serving the developer community. So if you wanted to have a photorealistic 3D human into your own application, you could go to one of these big volumetric capture setups, or you could do it with our technology just using your phone, which would be significantly cheaper and would allow you to iterate a lot faster. But what we wanted to achieve also was a way to reach marketeers and people that were presenting their own products, communicators, etc., without the need of having to go through, let's say, a full creative process with a developer. So they could directly go and buy it and use it, because that was the way that we thought we could scale the product more easily and faster, and also make it more useful for as many people as possible. So we decided to develop this new product called Hologram Messages, which is basically a way of delivering a message as a hologram, because that's how we call these 3D models. We call them holograms, not volumetric videos or holograms. We call them holograms. So you can deliver a message as a hologram. So it's normally targeted to people doing marketing, sales, internal communications, and it's been used for now for pitching different types of things, including your podcast is a good example. But we've had like an architectural company doing a project and presenting it as a hologram, and both as with the person, the lead architect, and also the full, let's say, site. In augmented reality, we had people introducing their new album, or introducing their startups, the events that they're going to be doing. And the idea is you send us a video with whatever you're recording. And normally, most of the times we receive videos captured with the phone. It is true that if you are able to get higher quality, so with a DSLR camera and a proper microphone, then the result will be better also. But we want to keep it simple. So even the hologram message example that we have, which is me, of course, pitching hologram messages, was captured with a phone, so no professional audio or anything like that. So, and the idea is that you send us the video, and what we return to you, it's a web AR experience using 8th Wall, if you're familiar with web AR, that you can already share and distribute. So this means that you don't need to get into developing anything, downloading anything. The only thing you do is just record yourself. So the whole process now is extremely simple. You send us the video, and there you go. You will receive a full web AR experience. We have different templates that you can choose from, and you can of course modify them and create your own unique thing. And right now we're pretty excited to see what people are actually coming to us with different types of ideas and things that they want to do with this type of communications.
And so, what are the case you're seeing? Because when I first talked to you about that, it was at the beginning we were launching the podcast, and for me I was like, oh yeah, that's going to be a great way to communicate. But that's, I guess, one way to use it. What are the other use cases that you're having, or how people are using it? Only to communicate, or for communication, or do you have any other case?
Yeah, I think that communication it's the key use case, right? But communication is also like a very broad term. It includes many different things, right? So marketing is a way of communication, sales is a way of communications, and in proper internal communications is of course another example. So these three cases are typically the ones that we're targeting, but we're all keeping our minds open. So just to give you a few examples of how people are using it. So we had a Spanish musician pitching their new album in augmented reality. We had Ori Imbar doing it last year for the first time for Augmented World Expo, pitching the event using also a hologram message. We've had a marketing campaign done by Dove Chocolates, so Mars Brightly, one of the biggest American chocolate brands, with supporting women entrepreneurs that were pitching their own companies. So their own these women were actually pitching their own companies in this marketing campaign done by Dove Chocolates. We've had also like another more training type of hologram message, which was about beekeeping, like from another company doing like beekeeping training and education. So in general, you see, it's whenever you want to deliver a message and you think that it's going to be more effective if you do it as a person than actually doing it as a like an avatar or like an animated or like a 2D video. But a 2D video, it's fine, but we're kind of tired already of saturated all this 2D video. So if you want to do it in a more effective way and you want to share it easily just with a link or with a QR code, we think that we can actually help you and you can do it as a hologram message.
Okay. So you explain the processes to get it and basically to be able to generate that hologram, and we saw that there's a lot of deep tech behind. So I'm guessing there's a heavy burden on the cost, I'm assuming, and therefore it's not necessarily a mass market product like we do pictures on Instagram or things like this. How far are you from basically going mass market to everybody? Because today your target is more B2B, right?
From a business point of view, yes. But the truth is that the very first glimpse of what our technology could do, the single view or 3D reconstruction technology, was an app that we released to the public called Volume. And actually, you can download it right now from the App Store and play with it and do your own captures for 5 seconds. So we think the technology is ready for the mass market. It might be more than the true, let's say, native ecosystem where this thrives is typically augmented reality, and probably we're a little bit early also in the augmented reality space. So we think that right now, if you want to do AR, it makes more sense to sell it directly to businesses, and that's why we've been focusing on selling it to the developers and the creators that are building these amazing experiences, but also the marketeers and the communicators directly through hologram messages. There is the first part of the question was about the cost, and the burden. So everything that we're doing right now runs on the cloud. So you do the recording, even if it's in the app, you do the recording on the app, and then it goes to the cloud. We do the reconstruction and return it to you. If we do it with hologram messages, it's the same. So it takes a little bit longer because typically there are longer messages. So there is a cost associated with doing it. When we do the free captures in the app in Volume, it costs us a few cents every time somebody does a capture. But I think that that's basically the price you have to pay, let's say, if you want to run very high-end complex AI models that run also fast, because we do have a version that works on device directly, and that costs us nothing. But it still takes too much time for the user to have to wait for it and keep the app open, and it uses a lot of battery and so on. So I think that for mobile devices, we're still a little bit far from being able to have a full product that works for at least for video. So we might be able to do it with images and static 3D models. So there is a cost, and of course we've worked a lot to optimize the processes so it takes the least amount of time possible, because that also means that it costs the least to process.
Processor usage. And how long does it take to rebuild the model? Like I know we worked on a 30 seconds video. What's the treatment process behind?
For instance, in the app, it's 5 second videos that we are allowing, and it takes around 10 minutes to process. We're of course optimizing for cost, not really for performance. For the 30-second videos that you were recording for your podcast, I think it could take like more or less 1 hour or so to process. We could optimize it and do it even at less processing time, but I think right now that's not the bottleneck. So we're focusing on making it highest quality more than running faster for the professionals.
Yeah, and after 1 hour, do you have to retreat the result by hand, or is it already at the level that we are seeing?
No, this is a fully automated process, and actually, as I said, you can try directly in the app. And the app, there's nobody's supervising anything. For the professionals and the hologram messages, we will do like a quality check just to make sure that everything went well. But there's no manual cleanup process where somebody gets the 3D models and now starts changing them or whatever. It's more to make sure that nothing went wrong and that the result that we're delivering is good. But there's no manual intervenence once the models are processed.
That's pretty amazing because I knew that I shouldn't have my hand in front of my t-shirt if I didn't want to have my hand printed on the t-shirt, basically, or that kind of weird stuff that we can find on your website. So Ludo was guiding me to make sure that my hand were properly set, but the result is pretty amazing. I couldn't wear my glasses, but still it works very fluently, actually.
Yeah, I think there's of course, when you're doing volumetric capture in general, you have to think about what are the limitations of the technology. And even if you go to a very high-end volumetric capture studio with 100 cameras, people from the studio will tell you, be careful, don't use glasses or don't use anything transparent because that's not going to get reconstructed. Or be careful on using these certain types of materials or certain types of movements because those could be problematic. So when you're doing it with one single video or one single viewpoint, there's other types of limitations. And of course, one of them is going to be resolution. We're using a neural network. So this means that we have to reduce the size of the images to be able to output, let's say, a full 3D reconstruction model. And this means that little details sometimes get lost. So that's why we train you and say, okay, you're going to be wearing glasses. The thin structures of your glasses definitely are not going to come, and it's going to look like your glasses are printed on your face, you're wearing some kind of mask. So it's better not to do it with glasses. But of course, we always leave it open and say, look, if you prefer it and you're not recognizable without the glasses, then course, go ahead and do it that way. The other thing that you mentioned about the hand, it's basically to help the algorithm, right? So we're trying to get we're getting a 3D model just from one single viewpoint. So which means that you're making a lot of assumptions about how you look from the back and how things are in terms of positions, just based on one single viewpoint, and that is tough. So if you put, for instance, your hands in front of your body, you're gonna create this occluded areas, like areas of your body that are not visible to the camera, which means that the algorithm is gonna have to guess. That doesn't mean that it's not gonna work. I mean, it actually works most of the times. But if you do it, you're risking it that for some reason, then maybe a finger is gone, and that finger might be printed on your t-shirt, as you very well said. So we said, okay, you want to do it, but keep in mind that these things might be problematic. So we want our clients to actually get the best result possible. So that's why we give you, a list of things that we recommend you do. For instance, if you are just like me and you like talking with your hands a lot, so instead of putting them in front of your body, instead of putting them in front of your body, just open them up a little bit more, as if you were presenting, and that it's perfectly fine for the algorithm, because it's not gonna create these occlusions, and then it means that the result is gonna be better. So it's always up to the client to decide what they want to do, but we have to be upfront, and give what we think are the best practices and things that you should follow to make sure that the result is as good as possible.
Of course. So I see time is clicking. Rafa, last question, because we talk about AR, and obviously the hologram is a AR communication. Does it change a lot of things for you, the announcement of Apple with the Vision Pro headset? Will it change something for you? What's your take on that?
Hopefully, yes. I think that I think everyone in the industry was pretty excited one way or another, about the announcement. It is an expensive device, of course, and I think a lot of people are not going to be able to buy it or to afford it, but it's basically a way of validating a whole industry that I think a lot of people still have questions about when you get Apple to get into the space. For us, it's actually perfect, because it's a new platform with a very well supported developer ecosystem that is going to require 3D models and 3D assets for their new experiences. So the same way that you were sharing your hologram message as a web link, and people were able to see it in web AR using their phones, we expect that there will be a way of also doing that, so your hologram message will show up directly into the 3D space within the Apple glasses, right? The Vision Pro. So I think it's perfect for us because it's actually a new platform, and I think there's going to be more people wanting to do things like this as soon as we start to be more familiar with these 3D spaces and environments more than the 2D screens that we're used to right now.
No, that's good. So are you guys gonna get one headset and start testing on it, or what's your plan?
Yeah, definitely. We'll have to see because we still don't even know when it's going to be launched. But and initially it's only going to be launched in the US. But I think we will for sure, just to make sure that we are among the first to port all of our technology, so to make sure that it works there. I'm pretty confident that it's not going to take too much to do because we already have an app that works on iOS with already plays our models, etc. So as they have said in the WWDC, the developer conference, that it's going to be relatively simple to port your existing apps and your existing content directly to the Vision Pro, and we expect it to be just like that. So hopefully it will be very simple to do.
Well, I can't wait to see the result. So Rafa, thanks a lot for this conversation. It was very insightful, and at least now I will be able to explain my kids what AI is using your Apple example, because they know about ChatGPT and how to basically do their homework on their behalf, but not much about what it is behind. So thanks a lot for this, and to all, see you soon. Thank you, Rafa.
Thank you very much.
Bye-bye, guys.